In statistics, we started chapter 9 on Friday, and that is hypothesis testing. So we started out by looking at the rules of making your null hypothesis and your alternate hypothesis. You can only use population symbols in your hypotheses. So that means I'm going to use letters like mu or p. You cannot use sample symbols, sample statistic symbols. So things like x bar, p hat, those do not go in your hypotheses. I guess they could ask about any population value, so you could be talking about sigma, could talk about the population median, who knows what, but typically we will only be using mu or p. In the null hypothesis, in H naught or HO, whatever you want to call it, we will always use an equal sign. So it's going to equal some kind of claim. And then our alternate, we're going to test if it's less than or greater than, or we may test not equals. So let's go ahead and practice with pineapples. And every problem we work, you want to start by asking yourself, is this a mean problem or proportion? Maybe hit pause, practice doing this. You want to describe the parameter. That's like the first step, this right here. That's like the first step of a confidence interval. And then you write your hypotheses underneath it. But maybe hit pause and try it out. This is a mean problem. We have numerical data, and I literally see the word mean typed, so that tells me that. So I lead off describing my parameter, true mean, weight of pineapples grown in a field in Hawaii. And then start your hypotheses. We have HO, I know that's H naught, but I don't know, I just call it HO. And HA, you guys told me it was a mean problem, or we decided that. So I'm going to use the Greek letter mu. The null, I haven't even read the details of the paragraph. I know for a fact the null is an equals, always, always. So then I'm going to go up and look for some kind of claim. It looks like we are curious if 31 ounces is the case. So that's the claim. And then notice how down here, managers wonder how this new irrigation system is going to affect that weight. It doesn't say they think they're going to be heavier or lighter. They just say they wonder how it'll affect it. It's very vague. Not less, not greater, not equals is implied or different. So that means HA is mu is not equal to 31. And that's it. That becomes our state step for a hypothesis test. All right, let's look at a few more things. A one-sided hypothesis test is when we use a less than or a greater than. This is a left-tailed test. I'll talk about what this tail thing is in a second. This is a right-tailed test. And it's it's called a tailed test, like right or left, or two-tailed test, because of that p-value you see defined below. Like a right-tailed test would look like this. We have our null, our hypothesized null, and we take a sample and we're going to get a p-value that's the shaded area. This happens to be a right-tailed test. I suspect that the true value is greater. We'll talk about that in a second. Two-sided is a not equals, also called a two-tailed test. That means that we are measuring both tails. You know, we still have our null, and we will get a p-value that's the combination of these two shaded areas. Now, what that p-value is a really difficult concept. People think it's the probability of the null, but that's just halfway right. Sadly, it's not even close. It's the probability of your sample statistic occurring, or anything more extreme, assuming the null is true. So if I want to say we had a claim of 31-ounce pineapples, and I'm testing to see if they're different than 31. I go on, I take a sample. Let's say in our sample we got 33. I do some stats, we'll learn that in the next lesson, and I calculate the p-value. This would be 31, that's my hypothesis. 33 is out here. I would calculate the area at that value and beyond. We've been doing that all year. But since it's two-tailed, I have to find the area of a value just as extreme as 33. So I would do 29. And the p-value is the probability of, whoops, I'm getting ahead of myself. P-value is the probability of 33 or any other x bar more extreme occurring assuming the null is true. Now, what is that p-value? That just depends on a lot of things. You know, if it was 0.1031, I'm just making up numbers, then that means there's a 10.31% chance of 33 or anything more extreme occurring, assuming the true mean is 31. It's a really difficult concept. We'll practice it more down the road. Let's do one more hypothesis and call it a day. Maybe hit pause and then give it a try on your own. This is a mean problem. We're talking about the true mean calcium intake of teenagers. We need our null and our HA. It's a mean problem, so we're doing mu. The null is always equals. We're concerned about 1300 being that decision point. I realize 1400, 1500 is okay, but 1300 seems to be that cutoff value. So I have to write 1300 here also. And I suspect that the true mean is smaller. All right, we'll practice this more down the road. See y'all on Monday.